Nadi Jani beli nadi Jani beli nadi Jani beli nadi.
to my release branch. So you want to make this procedure as easy as possible, so it doesn't, become too much of a hurdle for the developers. So they kind of built-in support for this workflow, and of course this is Git, so you can do cherry picking in a lot of ways. But it's kind of nice to do it in this way because now you also automatically get a pull request, because pull requests will then be associated with running builds and other kinds of verification along the way. So you don't make this quick fixes. So that's nice. So okay, so what are the benefits around this trunk-based development? Well, first of all, clearly you minimize the merge conflicts, the work around merging, because everybody's committing into master. And along this line, it also encourages making really small batches of work. Because if you are a team of 10 developers working continuously and use it and work locally for a long time with your commit, the changes start to pile up locally. You know that this will probably be a problem for me if I don't commit frequently. So it kind of encourages you to work in small batches, in small changes. And that's a really good thing to do. It also encourages refactoring, as I mentioned before. And in general, teams experience that they get better delivery throughput. So the team gets more and more focused on delivering stuff consecutively into production. So how can we do this? So I talked about like how it works with the branching and so on, but clearly there are more things to look out for here, because if we just committing code into master, won't that break a lot of stuff? That's a general fear, and of course there's a big risk for it, so you need to think about it. So first of all, you need to work in, as I mentioned, small incremental batches of work, and these changes in general need to be compatible, because you need to be able to deploy this stuff along the way, because everything going into master should be ready for release. But when you're working on new features, it will take more than a day typically to finish a feature. But these commits will go into production anyway, so you need to find ways to hide this work until it's finished. And to do that, you usually use feature toggles in a way to hide this feature from the end users until it's done. So we're going to talk about that. Also, you need to think about ways of enforcing quality in your changes, and you want to do that as soon as possible. As much as possible of this quality work needs to be done before the change actually ends up in master. Of course, you will still have this pipeline after master, and it will go through different stages, and you run tests against it. But the shorter this feedback loop is, the better. So you want to do things like, of course, running verification builds, running unit tests, doing code review, etc., etc. All these things to make sure that the code going into master is of as high quality as possible. And at the end, eventually, sooner or later, you will deploy bad code into production. Possible of this quality work needs to be done before, take more than a day typically to finish a feature. But these commits will go into production anyway, so you need to find ways to hide this work until it's finished. And to do that, you usually use feature toggles in a way to hide this feature from the end users until it's done. So we're going to talk about that. Also, you need to think about ways of enforcing quality in your changes. And you want to do that as soon as possible. As much as possible of this quality work needs to be done before the change actually ends up in master. Of course, you will still have this pipeline after master, and it will go through different stages, and you run tests against it. But the shorter this feedback loop is, the better. So you want to do things like, of course, running verification builds, running unit tests, doing code review, etc., etc. All these things to make sure that the code going into master is of as high quality as possible. And at the end, eventually, sooner or later, you will deploy bad code into production. Everybody does that for any kind of reason. And when you deploy stuff often into production, you want to make sure that if you're deploying bad code, if you get a problem, you want to try to make that problem impact as few users as possible. So instead of deploying a new feature to everyone across all your environments, environments, try to minimize this, do this incrementally. So I'm going to talk a little bit about some deployment techniques that you can use for trying to make safe deployments. Okay, so feature toggles. So the concept is really easy. You have this maybe web page. You have a boring grid there, and you want to change that into a fancy ways of enforcing quality. Because if we just committing code into master, won't that break a lot of stuff? That's the general fear, and of course there's a big risk for it. So you need to think about it. So first of all, you need to work in, as I mentioned, small incremental batches of work. These changes in general need to be compatible, because you need to be able to deploy this stuff along the way. Because everything going into master should be ready for release. But when you're working on new features, it will take more than a day typically to finish a feature. But these commits will go into production anyway, so you need to find ways to hide this work until it's finished. And to do that, you usually use feature toggles in a way to hide this feature from the end users until it's done. So we're going to talk about that. Also, you need to think about ways of enforcing quality in your changes. And you want to do that as soon as possible. As much as possible of this quality work needs to be done before the change actually ends up in master. Of course, you will still have this pipeline after master, and it will go through different stages, and you run tests against it. But the shorter this feedback loop is, the better. So you want to do things like, of course, running verification builds, running unit tests, doing code review, etc., etc. All these things to make sure that the code going into master is of as high quality as possible. And at the end, eventually, sooner or later, you will deploy bad code into production. Everybody does that for any kind of reason. And when you deploy stuff often into production, you want to make sure that if you're deploying bad code, if you get a problem, you want to try to make that problem impact as few users as possible. So instead of deploying a new feature to everyone across all your environments, try to minimize this, do this incrementally. So I'm going to talk a little bit about some deployment techniques that you can use for trying to make safe deployments. Okay, so feature toggles. So the concept is really easy. You have this maybe web page. You have a boring grid there, and you want to change that into a fancy graph. But that will take a while. I can't make that in 2 hours and commit it. I need to work for a couple of days, or perhaps longer. So you create a feature toggle, and feature toggle is just an if-else statement to keep it simple. And you deploy this with this feature toggle turned off, so the new graph is there, but it's not visible for the end users. And after 1 week, perhaps, it's ready, and it's time to turn the switch on, and now the users will see this new graph instead of that boring table. So this is a principle, and as I said, this is a glorified if-else statement. So the toggle itself is nothing fancy, so to say. And Martin Fowler, of course, has a long article around feature toggles, where he also classifies these toggles, and along the line of one line you have this dynamism of how often does a feature toggle change. So like in one end of the spectrum, you change the toggle when you release something, to where you actually change it with every request. For example, determining what kind of role the current user have. On the other, on the y-axis, you have the period of time that this feature toggle should exist. And in many ways, you want to keep this toggle short-lived and remove them when it's done. But some of these toggles, for example, around permissions, this is role-based security, really. If I am an administrator, I should see this screen. If I'm not an administrator, I should not see it. That's really a feature toggle, if you want to call it that. So they will live for a long time. If you have feature toggles, you can, in some cases, actually let users themselves turn them on and off. So this is also from Azure DevOps, where they are exposing. They have, of course, a lot of feature toggles internally, but some of them are exposed to the end users. So I can select these features myself or for my team. So and this is really a win-win situation, because I can get to use new features that might solve problems for me. And Microsoft, in this case, will get valuable telemetry back from users using these preview features. And if they would cause me any problem, then I can just switch it off. So this is a really nice idea to use that. So when you're implementing feature toggles, the question is, okay, where should I put them? So let's pretend you have this UI, and the UI calls an API, and you have some logic, and you have some storage along the way. So let's say I'm working on adding some new, maybe that new graph that we just talked about. Where do I need to add, or where should I add my feature toggle code? Well, obviously, I have to add it in my UI because that's where I'm changing stuff. So is that enough? Well, so do I need to actually put it somewhere else? Well, in this case, maybe the UI calls a new endpoint on my API. Okay, but if the UI isn't visible, it will never call that endpoint, right? So I don't need to put a feature toggle there. Or do I? Because the thing is, that endpoint will actually exist there. It will be exposed. So you need to think about these things, that if you're adding new endpoints, even though you're not calling them, someone else might call them. And you need to think about security as well. So don't put out new endpoints without any security just because you're not calling them. So in general, you want to put your feature toggles as high up as possible, as early as possible, but don't forget these publicly exposable layers. But you probably don't want to put it down here because there's no point in like duplicating this if-else checks all the way down here. That doesn't give you any benefit. It just gives you technical debt, really. So, okay, so let's in the case where I just talked about, if you have a web page and you just want to add something to it, that's the easy case. You just wrap that stuff with a feature toggle. But sometimes you make more changes. Maybe you're removing stuff, you're moving stuff around in your web page, you're adding stuff, you remove something else. So now it becomes kind of a cumbersome. If it's that many changes, do I need to put like 15 if statements in my web page? Probably not. That's probably not a good idea. So somewhere along this line, you need to think about security as well. So don't put out new endpoints without any security just because you're not calling them. So in general, you want to put your feature toggles as high up as possible, as early as possible, but don't forget these publicly exposable layers. But you probably don't want to put it down here because there's no point in like duplicating this if-else checks all the way down here. That doesn't give you any benefit. It just gives you technical debt, really. So, okay, so let's in the case where I just talked about, if you have a web page and you just want to add something to it, that's the easy case. You just wrap that stuff with a feature toggle. But sometimes you make more changes. Maybe you're removing stuff, you're moving stuff around in your web page, you're adding stuff, you remove something else. So now it becomes kind of a cumbersome. If it's that many changes, do I need to put like 15 if statements in my web page? Probably not. That's probably not a good idea. So somewhere along this line, it's usually better to just keep this old page and start working on this new page in parallel with the existing one. And they would use routing to, so if this is the order page, this existing order route will just keep working. So all users will be directed to the existing page, and then you as a team can start working on this other page. And of course, there will be some duplicated code here because you're basically copying the old one and start working on it. But that's fine because this is for a short period of time. And when you're done, you can remove the old screen. But now you can also add, feature toggles to the mix because when you're almost done, you're perhaps ready for a preview. So then you can actually enable this new screen for some pilot customer, for example, to get feedback. So feature toggles gives you this kind of nice way of exposing functionality to certain users and allow you to get feedback for it. So about implementing feature toggles, there are, I would say most companies that do this, they roll their own ones, they build this themselves, and it's not that complicated. And there are several different frameworks. This is for around .NET, so the end feature toggle and so on. But this is now so common, so there's also multiple different solutions out there that actually implement feature toggles as a service. So Launch Darkly, Rollout IO, Split IO, and there are more of them. They have SaaS services for implementing feature toggles for you. So instead of you calling your own code to ask if this feature available for this user, you'll call this service instead. And the nice thing is that they then also they have extra additional functionality around feature toggles. So it's not just answering yes or no on my question, because you can build functionality around feature toggles. So I just want to do a quick demo of Launch Darkly, which is one of these services. So in this case, I have some old demo application called Parts Unlimited from Microsoft. And I'm working on a new feature, which is the member portal. So and this is now hidden. It's going to show up to the top right, but it's now hidden behind the feature flag. And I can just quickly show you the code, what it looks like. So in this case, it's very easy. I use my SDK for C#. I send in the current user as the key, and then I'm asking, is this feature called member portal? Should that be turned on for this user or not? So it's very, very simple. So with Launch Darkly, then I get this I have an account there, so I get this dashboard where I can create multiple products, and each product can have a set of feature flags. So in here I created this feature flag called member portal. It's currently turned off, so let's turn it on. I have to confirm it that I really want to turn it on. So, and if I refresh this page, I now get this, this member portal. So this is a very easy example of, so now this might seem like an overkill. Why do I need to call this external service just to ask about this feature? Is it turned on or not? So you get, typically from these services, you get a lot of extra services around this. So, you get, first of all, you get this nice dashboard just turning things on and off again for users. And you get the statistics to see, is this feature flag used? How often is it used? And so on. You can also connect things like goals. So kind of like A/B testing. So you see that if I create this feature flag, if I show a new UI for a user, will that user is it more likely to, buy my products, for example? So you can create goals around this. And target specific user groups and see are my feature making sense for my users and so on. So and the other solutions have similar functionality around this. Has anybody used any of these services? Yeah. Launched darkly. Okay, yeah. So some considerations around feature toggle. So in general, you want to have as few as possible. And remove them when you're done, and they should be as high up as possible in your code path, so you're not duplicating these checks all along the way, because it can become a real mess having all these if-else statements. So remove and done, and some of these services also have this functionality around, is this feature flag being used, or is it always returning the same value for a certain period of time? Then that is a signal that you should probably remove this feature flag from your code. Because, as I said, you don't want to have like lots of if-else statements lying around in your code base. Of course, you need to use telemetry along this way if you want to make sense of these feature flags. How is my code being used by my users when I turn this feature flag on and off again? That is what it will allow you to do, A/B testing and all those sort of things. A common question is, okay, but do I need to test all these combinations? So if I have 4 feature flags and they can be on and off, that's 16 different combinations. So do I need to test this software 16 times? And of course, in an ideal world, you would do that, but that is feature flag from your code. Because as I So some considerations around feature toggle. So in general, you want to have as few as possible, and remove them when you're done. And they should be as high up as possible in your code path. So you're not duplicating these checks all along the way, because it can become a real mess having all these if-else statements. So remove and done, and some of these services also have this functionality around, is this feature? So you're not duplicating these checks all along the way, because it can become a real mess having all these if-else statements. And remove them when you're done. And they should be as high up as possible in your code path. So you're not duplicating these checks all along the way, because it can become a real mess having all these if-else statements. So remove and done, and some of these services also have this functionality around, is this feature flag being used? Or is it always returning the same value for a certain period of time? Then that is a signal that you should probably remove this feature flag from your code. Because, as I said, you don't want to have like lots of if-else statements lying around in your code base. Of course, you need to use telemetry along this way if you want to make sense of these feature flags. How is my code being used by my users when I turn this feature flag on and off again? That is what it will allow you to do, A/B testing and all those sort of things. A common question is, okay, but do I need to test all these combinations? So if I have 4 feature flags and they can be on and off, that's 16 different combinations. So do I need to test this software 16 times? And of course, in an ideal world, you would do that, but it's not very realistic, certainly not for manual testing and not even for automated testing. So in general, I see companies compromising and say, let's test it with all flags turned on, and let's test it with all flags turned off. And then in some cases you might have combinations, but in general, at least those two cases should be handled. And that can be handled pretty efficiently by your deployment pipeline. First you deploy it and switch on the flags and run tests, and then you switch off the flags and run the same test again and verify that everything works. And again, don't ship security holes. Think about these endpoints that you're exposing. So shift left is this kind of trend around pushing quality as soon as possible in your pipeline. This is not really related to shift left, but I thought it was funny. I guess it's a tennis game or something. And you really wonder, what is he looking at? So, you have this deployment pipeline, your process of work where change is coming in, and you have your CI pipeline and deploying stuff into production. And this is could be a lengthy process. And so this is about ensuring that you're checking your quality as soon as possible, as fast as possible along the way, instead of waiting and running all the tests in the end. Let's do it as soon as possible. So if you are using pull requests, then this is a great place for doing a lot of this work. So code review is an obvious thing to do if you're doing pull requests. This will allow your team members to have a look at your code for design guidelines, for the 4i principle. But you will also connect typically an automated build for your pull requests, and that allows you to do things like doing code analysis, security checking, and of course running a lot of unit tests and perhaps some fast integration tests. So this is now run before anything actually hits the master. That's really important to think about. Once the code is in master, we will of course continue to run tests against it. Then we typically deploy this into some test environment, and you run some functional tests against it. And those tests are typically slower, so that's why we want to run them a bit later. So as I mentioned, pull requests is a great place to do this, and most solutions out there have this concept of guarding your branches. So in Azure DevOps, you can set up a set of policies for your master branch to make sure that things are checked before going in there. So in this case, I'm demanding that every code change needs to be reviewed. I have to link the change to a work item describing why I do this change, and I need to run a build that needs to be successful before I'm allowed to merge it into master. And you can add additional things like calling external systems and so on. So this is a great place to run these checks in. But of course, testing is really, really important here. That is really what's going to save you from a lot of deploying bad code into production. So this is the famous test pyramid that tries to describe what typical types of automated tests, plus you have manual tests at the bottom. So this is what it should look like. You have a lot of unit tests at the bottom, then you have some integration tests, the test may be on the API level, and at the top you have some UI tests that actually test the entire system, and you do some exploratory manual testing. Now, the reality is very often you turn this around. This is called the ice cream cone anti-pattern because it looks like an ice cream cone. And this is very common, that it looks like this. So one of my current clients are in this situation. They started investing heavily in automated tests a couple of years ago. And the thing is, when you start working on a kind of a legacy code base and you want to add tests to the mix, it's really hard to just start writing unit tests, because very often the code isn't really designed to be testable. And even if you start creating unit tests, you get very, very little code coverage in the beginning. So it's kind of a mental thing. It feels kind of, this doesn't give me anything. It takes time to get code coverage from unit tests. So it's very tempting now to do some tests on higher up in the chain, like integration tests or even UI tests, because they're not that hard to write. They're sometimes even easier to write than the unit tests, and they give a lot of code coverage. You can click around, using Selenium, for example, you can click around and hit a lot of code here. So it feels very nice in the beginning. But the problem is that you keep working, you get more and more of these tests, and the problem with these tests are they are first of all very, very slow. They're like 1,000 times slower in general than the unit test. But even more problematic is that they are, when they fail, they tend to be very flaky. So so this customer that I mentioned, they typically have a certain amount of flaky tests every night, and then they just rerun the tests. It's very common because they know that eventually it will pass. So they rerun it multiple times. And this is not uncommon. And some tools, I think Azure DevOps has this option of rerunning failed tests. So they are not alone, for sure. And also, if the test fails for a valid reason, it's very hard to track that error down because it can be caused by so many things. If you're hitting the entire system, why did it fail? So it takes a lot of time to track down failed tests every morning. So I want to talk a little bit about some kind of a public case around this that Microsoft has published. So they have been doing this huge transformation the last couple of years from being this dinosaur delivering software every 2 years into this cloud native company deploying all the time. And they publish a lot of very interesting articles around this. So I really recommend you. I include the link here. So go ahead and read these articles because it's really interesting how you can do these things at scale. So they were pretty much in the same situation as this customer talked about. So they had what they called nightly tests that took 22 hours. After those nightly tests, they ran full automation run tests, which took up to 2 days. And again, these tests failed frequently, which resulted in developers didn't really pay attention. They just left it. And so at the end of the sprint, that's when when they were kind of feature complete. Then they said, okay, let's start fixing these tests. And that could easily take another sprint, just fixing these tests, because they just postponed it and the tests were so hard to track down. So this was really slowing them down and causing a lot of frustration. So they did kind of this retake along with lots of other things. So back to this is 4 years ago. They stated some principles that should be true for working with tests. When they were kind of feature complete, then they said, okay, let's start fixing these tests. And that could easily take another sprint, just fixing these tests, because they just postponed it and the tests were so hard to track down. So this was really slowing them down and causing a lot of frustration. So they did kind of this retake along with lots of other things. So back to this is 4 years ago. They stated some principles that should be true for working with tests and test automation. So things like tests should be written at the lowest level possible, prefer unit tests over anything else. And the product must be designed for testability. Things like test ownership follows product ownership. So the team working on a specific part of the product, they should also be in charge of the tests. So this is cross-functional teams. So you have both developers and test engineers and QA on the same team because it just makes so much sense. And what they also did was that they created this test taxonomy. And And so this is one way of doing it, and it's I think it's a pretty nice idea that you categorize these different types of tests. So instead of before they talked about how long this test took to run, so they had nightly tests and full automation run tests. Now instead they said that That let's look at the dependencies of these tests. So you have like the unit test and functional tests. So there are 4 different categories where the L0 one is the pure unit tests. They have no external dependencies. They can run in memory and they can run really, really fast. And they also set like this thresholds. They should not take more than 60 milliseconds to run any given unit test. And if it's slower, the build will fail. So they enforce that. So the next step is the L1 test. So that's a unit test, but it has some external dependencies. It might hit the database. So this is for the Azure DevOps system. It's pretty heavy on SQL Server. So that's why in this case they allowed you to write tests targeting the SQL Server, and that of course will be slower. So average is around 400 milliseconds, and it can't be over 2 seconds. Then that test will fail, and so on. And then you have the functional tests, and these are then executed, on deployed systems. So the L2 ones are deployed, run against test system, and the L3 ones they are actually running against production. So this is test the full deployment, and they're doing this in production. So this is really testing in production that used to be a joke is now a reality, because it's almost impossible to have a staging environment that is identical to your production environment. It's a lot of work to just restoring data and keeping up to date with all changes. But even if you do, you still don't have the same amount of users testing your stuff. So it just makes more sense to run some of these tests in production instead. And they worked around 2 years, going from this old slow tests, the orange one, gradually replacing them with this new faster type of tests. So over here, around 2 years later, they have these L0 tests, which is then maybe 90% of the tests are unit tests, and then they have a few functional tests that are executed as well. So this is the slide I saw from Microsoft. So this is the current PR build. This build is run on every pull request. And at this point in time, they're now running 84,000 unit tests on every PR build. And it says 18 minutes here. I think I saw lower numbers, but so maybe it's a bit up now. It used to run around 10 minutes. And this is important to keep this loop fast. It shouldn't really be more than 10 minutes. So I think they need some more build servers perhaps to speed these things up.
Maybe some of my current favorites, for example, the RG351V, which has the same screen as The only thing that's different is the I/O. The volume to max, and you're going to hear that there's some distortion. Also, you can't hold down on these buttons. You have to just push them a bunch of times. Kind of annoying.
Okay, so what about deployment? As I said before, even if we have all these quality checks, we will still deploy stuff into production that will cause problems. So, as I mentioned before, we need to think about request, and at this point in time, they're now running 84,000 unit tests on every PR build. And it says 18 minutes here. I think it's I saw lower numbers, but so maybe it's a bit up now. It used to run around 10 minutes. And this is important to keep this loop fast. It shouldn't really be more than 10 minutes. So I think they need some more build servers perhaps to speed these things up. Okay, so what about deployment? As I said before, even if we have all these quality checks, we will still deploy stuff into production that will cause problems. So, as I mentioned before, we need to think about ways of deploying new versions that doesn't hit all my users at the same time. So instead, try to roll out new versions incrementally. So this is things like canary releases or dark launches. Two ways of describing basically the same thing, that you're not deploying everything at the same time. Instead, you're deploying it in stages. Also, this concept of separating a deployment from a release, and this is really what a feature toggle gives you. So deployment, that's actually deploying new bits to your servers, but release, that's actually turning on a feature for a user, and that's two different things. You don't have to deploy it and make it visible at the same time, because that's a big risk in general, because the deployment can go wrong itself, or the feature itself could be incorrect, and so on. So if you first deploy it, then you let the system run for a while, make sure everything is good, then you turn the feature on. That gives you an extra safety guard. And also try to implement automated release gates along the way here. Try to remove manual tasks and make sure that everything looks good. And I will show you some examples of that. So a canary release. This is, you divide your user base into different groups, where you call the first group canaries. And this comes from this the concept of the coal miners going into a mine. And to make sure that there wasn't any toxic gas there, they sent in this canary bird first, and if that canary bird kept singing, then you're like, okay, that's fine. That we can go down there. It's safe. And you can think about your software in the same way as toxic gas. Really, is this new version toxic or not? Let's hit it. Let's throw it to these canary users, these fools. So this is very common, and so this is an example from Windows, how they roll out Windows. So is anybody in the fast ring of the Windows? So some of you, so you get new versions faster than everyone else, you think, but before you get it. a lot of rings had already been taken place inside Microsoft. So they have their set of canary users, and then the operating system group gets it, and then Microsoft gets it, and then you get it in the fast ring. It's not as fast as you thought. This is from Azure DevOps. So this is kind of, they're deploying Azure DevOps using Azure DevOps, of course. And they also have this concept of deployment rings, where the first ring is Microsoft themselves, and for example, MVP accounts. I have an account in the first ring, so I get the new version as fast as possible. But this is their canary ring. So sometimes I get stuff that isn't really production ready, and they have to turn it off again. But I get to use cool stuff first. And then the next ring is one of the data centers. I don't remember which one, and then they kind of grow exponentially. So a full release in this case typically takes around a week, because they deploy here to rings here on Monday, and then let it cook there for like 24 hours, make sure everything looks fine, and then they move on to the next ring, and then the next ring, and so on. And if they notify problems, then they can stop there, and at least all users haven't been exposed to it. So if you combine this with feature toggles, you really have a mechanism to protect your users from your bad code, really. So you have this CD pipeline where you build your artifacts, and then you deploy it to your canary users. So you deploy it, and everything looks good. Then you can swap this feature toggle and have this could be multiple feature toggles. And now your users can test this new functionality. So typically you add monitoring telemetry to the mix here to make sure that everything looks good. And then after a certain amount of time, everything looks good, you go into the next stage and you approve it. And then you can deploy to early adopters, you flip the feature flags, and so on. And again, if something is problematic along the way, you can stop there. And the last one, this should be like the big one. So here you have perhaps 90% of your user base. They would never see this new feature because it hasn't been deployed at all into their environments. So this requires you to actually physically separate your users into different environments, so you can deploy new versions to a targeted set of groupers of users. Dark launch is really kind of the same thing. You might hear this term once in a while. It's really the same thing as a canary release, but it's typically used for deploying back-end changes. Perhaps you're doing performance work, but you're kind of scared because they only a real good way of validating performance improvements is to run it in production. So typically you deploy this change behind the feature flag into production. You flip the feature flag on for certain accounts, perhaps, and this is now being executed in production, but your end user doesn't really know it. That's why you call it a dark launch. And when everything is good, you just remove the feature flag and you're up and remove the old code base or the implementation. So release gates. So this is a know it. That's why you call it a dark launch. And when everything is good, you just remove the feature flag and you're up and remove the old code base or the implementation. So release gates. So this is a thing of along this line of deploying stuff into production. You want to make sure that everything looks good, and that takes a lot of work. So you want to automate as much as possible here. So you want to have a process that just keeps on going without too much manual intervention. So some examples here could be, for example, incident management. So you deploy stuff, a new version into some test environment. And then perhaps you check your incident management system. has any high priority bugs being posted the last 2 hours. If not, then you can automatically just go on into production. So then you have this fixed schedule of 2 hours after the last deployment to test. This will go into production unless we have a high priority bug, for example. We could also check user experience. So this is using monitoring telemetry from your test system to see that has, for example, number of failed requests gone up since we deployed the new version. If so, that could be a signal that we should not proceed, and then maybe we stop here. We can also call external systems to ask for verification. We can check the infrastructure health, for example, for our production environment. So before deploying into production, check the health of the production system. Because if that's unhealthy at the moment, maybe it's not a good time to deploy a new version at the same time. And these are things that you can check in an automated way. You don't need to do this manually. And I wanted to show you a demo of how you can do this in Azure DevOps. And other tools have similar solutions for this. So this is a deployment pipeline I have for a sample application, where I have deployed it into a test environment. Then I ran a few functional tests, and then I want to go into production. But now it's currently waiting here to go into production. And so the reason it's waiting now is because I added some release gates to it. You can see back there. So in this case, I defined 2 release gates for my production environment. So the first one checks, just the case I talked about, check work items. So check my incident management system for high priority bugs. And in this case, there is a bug because I created it before. So I have a bug that is marked as high priority just in my incident management system. And that's why it's now waiting. It won't deploy it into production. At the same time, it's also querying Azure for monitoring alerts. Has there been any alerts recently in my production environment? In this case, it hasn't, so that gate is green. But I have 2 gates, and both of these gates need to be marked as green before it will actually continue. And I'm just going to show you what it looks like, how we implement this. So in my production environment, I have enabled gates. And I will try to zoom this up. So I have these two gates, and does this work? So, and these are there are more you can actually install now, but there are a set of gates that you can use here. And as you see, you can call an Azure function or a REST API here, and that means that you can pretty much check anything here in your systems or wherever, and make sure that everything looks good before going on. Actually, so there is a sample from Microsoft where they actually check Twitter. So they call it the Twitter sentiment analysis. It's actually valid for some customers. So the idea is that you deploy stuff into maybe a canary set of users in production, and then they monitor Twitter. And if people are writing about their system in a bad sentiment, in a bad mood, negative words, this release gate will actually stop, because it seems like this could be a potential problem. If people just started writing bad stuff about our product, it could mean that we just deployed some bad code here. So it's an interesting way of using this kind of feature. All right, so that's pretty much it, actually. So I talked different ways here how you can make trunk-based development work, and I just want to end with this quote from Jess Humble, the author of the Continuous Delivery book, which I think makes a lot of sense. So he says, trunk-based development is really about putting the needs of the team above the needs of the individual, and this is really true, because all these things that I talk about, if you talk to a developer about this, it's a very common reaction to think that this is it's more work for me. I used to be able to work in my branch over here, and I was very efficient at it. And that could actually be true. Maybe that developer was more productive in his branch alone, but the team wasn't. So it's really important to see the needs of the team, the needs of the company here, instead of focusing on my need. So I think this quote makes a lot of sense actually, and this is of course valid of a lot of process things out there. So with that, I would say thank you, and again, come to our booth outside here to try AI Clippy, and also sign up if you're interested in doing bank ID integration. You can get some test vouchers there to do it for free. So thank you.